Okay, so on Thursday, you have a test. And so this video goes over all the questions on your Unit 6 review. And I'm also going to talk a little bit about the test questions that correspond with it. Feel free to stop, pause, copy this information down and study it. There will be 25 questions on the test. There's 24 questions on here. There's a direct correlation between those review questions and the questions that are on the test. So first off, mechanical waves require a medium to travel through. So remember, the difference between a mechanical and electromagnetic wave is that mechanical waves require something to move through. An example of this is a sound wave or even a wave in an ocean. They require a medium to move through. Electromagnetic waves do not require something to move through. Number two, transverse waves make up electromagnetic spectrum. So the electromagnetic spectrum does not require a medium to move through. And it has a range of things that exist on it, from microwaves, radio waves, UV rays, X-rays, etc. Okay, all of those waves are transverse waves, meaning they have that crest, that trough, they have an amplitude, and they move at a 90-degree angle from the direction in which they are moving. The only type of wave that you can see on the electromagnetic spectrum is visible light, right? And we talked about Roy G. Biv, right? Red, orange, yellow, green, blue, indigo, violet. All of those are the components of visible light. And those are the only wavelengths that we can see, only those frequencies that we can see that exist on the electromagnetic spectrum. You remember the electromagnetic spectrum is going to be all transverse waves, and they're waves that can travel without the use of a medium. Number 4 is all about frequency. Remember, frequency is the number of waves that pass a fixed point in a certain given amount of time. So it's how many waves go past a specific point over a period of time. And then a wavelength is the distance from crest to crest or trough to trough. And the longer the wavelength, the lower the frequency, the shorter the wavelength, the higher the frequency. Okay. Also, when we've been talking about how we perceive color, if we see a color such as blue, this means that the item is absorbing all the wavelengths and it's reflecting a blue wavelength back to us. So an example we used in class was a green plant. If a plant is green, this means that that plant is absorbing all that visible light. It's absorbing the reds, the orange, the yellows, the blues, the indigos, and violets. It's not absorbing the green wavelength, and because it's not absorbing the green wavelength, it reflects it back. And because it's reflecting it back and bouncing that back to our eyes, that's what we're able to interpret and see. Number 7 is light is transmitted through a window. So the way that light interacts through a window or any transparent material is that it is able to move through that material. A wave is a disturbance that transfers energy from place to place. Remember, it doesn't move matter, it moves the particles. So as that energy moves through the wave, it causes the particles to go up or down, up or down. So a wave is simply a disturbance that transfers energy from here to here. And as it's transferring that energy, it causes the particles to move. And how those particles move, whether it's up and down in a transfer waves or side to side, as in a longitudinal wave, it's only moving those particles as the energy moves from here to here. And then a medium, remember that mechanical waves require a medium to move through. So a medium could be a solid, it can be a liquid, or it can be a gas. And of these three, remember that a wave moves the quickest through a solid, then a liquid, and the slowest through a gas. And the reason that is because a solid has more particles, and those particles are densely compacted. And since they're densely compacted and they're vibrating in place, they have that sound wave, or the wave that travels through the solid, has all of these particles to vibrate. And as they're vibrating, it makes that wave move quicker through. If we compare that to a gas that has these particles everywhere, as that wave moves through, it doesn't have as many to move through. So it has to go find them. And as it moves through, it's going to move slower. So the quickest one it moves through is a solid. This way you can put your ear to the ground and you can hear people coming. All right, 11, so the waves that are produced with someone's voice and the waves that are produced when someone jumps into a pool is the same type of wave because they're both mechanical. They both require a medium to transfer through. So think about the lab that we did where we put the drop of water into that pan. Remember that drop of water created these ripples and vibrations out. Those ripples and vibrations out means they're both mechanical waves. It's same with our voices. A sound wave is a longitudinal wave in addition to being a mechanical wave because the vibration of the medium is parallel or along the same direction of the wave. So remember, transverse go up and down like this. Like a traditional wave, it travels 90 degrees from the direction it's moving. A sound wave is going to bounce back and forth. All right, so these are the three different ways that light can interact. You have refraction, reflection, absorption, and transmission. And this is what we just finished talking about this week. Refraction is when light bends, right? So it's going to bend as it moves from one medium to the next. So like when we did the lab with the pencil, we put the pencil in the water, you saw the differences in how that pencil looked when it was in a gas versus when it was in a liquid. So that bending of the light wave causes refraction. Now, when a light wave or a wave bounces off, like with an echo or when you look in a mirror, that is known as a reflection. So the bouncing off is a reflection. If a material is going to absorb wavelengths, it's absorption. And then transmission, like with light coming through a transparent material, like a window, it is transmission. It transmits all the wavelength through. Very few is lost to reflection or absorption. All right, 13, a pencil looks like it is bent when it is placed into water because of refraction. When the light waves bend differently when moving through different mediums, this causes a change in the speed. And because of the change in the speed, you see a bending occur. And so that's what we call refraction. Now, if you move through visible light on the electromagnetic spectrum, so if we're going from red to orange to yellow to green to blue to indigo to violet, so as we're moving from closest to infrared to UV, your wavelengths become shorter and the frequencies get higher. So as you go from red to purple or to that violet, you are having your wavelengths get shorter and that's going to increase your frequency. Now a higher amplitude means a higher frequency. A higher amplitude means a higher frequency. So the amplitude, remember, is the distance from the rest position to the crest. That distance, as it increases, we get an increasing amount of energy. And as we have increasing amount of energy, we have more frequent waves. More waves are going to pass that point. So the longer the wavelength, the lower the frequency. The shorter the wavelength, the higher the frequency. Remember, it's an inverse relationship. We've been talking about this from day one. The longer the wavelength, the lower the amount of waves that pass a specific point. The shorter means more waves are going to pass a specific point at a certain time. Now, this goes into how much energy does a wave carry. So the higher the frequency, the shorter the wavelength you will have, which means you will have more energy. The longer the wavelength, the lower the frequency, the less energy. Also, a high amplitude means high energy. A low amplitude means low energy. A transverse wave is a wave that travels at a right angle to the direction of the wave. For example, ocean waves or electromagnetic waves. So some couple of different types of waves that exist on the electromagnetic spectrum. One is an X-ray. Remember, X-rays can travel through tissues, but not through bones. It is used to make images, and this is a type of electromagnetic wave. Another type of electromagnetic wave is a gamma ray. It has the shortest wavelength, which means it has the highest frequency and has the highest amount of energy. Because of this, it can cause cancer, but it can also cure cancer. And then microwaves. Microwaves are used in Bluetooth, they're used in cell phones, and they're used in Wi-Fi. Radio waves can transmit radio and television signals. This is also a type of electromagnetic wave. Remember that sound waves move quicker in warmer temperatures because they have more energy and they have more ability to move through and vibrate the particles. Now waves, remember, move the quickest through a solid, then a liquid, and the slowest through a gas. And then finally, an echo is a sound wave reflection. Okay, so on Thursday, you have a test. It is 25 questions. Study this material, rewatch this video. There's 24 questions here. And I can tell you that the 25th question is going to be about the solid and how quick a medium moves through. Which one does it move through the fastest? Because it was mentioned twice, but it didn't have a question on its own. So the 25th question is going to be about which medium does a wave move through the quickest? And the answer is solid. So study these 25 questions. If you study these 25 things, you will do fine on the exam. Remember, your ISN will be checked at that time. If you have any questions, please let me know. We will have tutoring Wednesday night at 6 p.m. Thank you.